Hello students, today we will study Coulomb's law in electrostatics. This is analogous law in electrostatics to Newton's law in gravitation, okay, in classical mechanics. Let us first see some important points about Coulomb's law. First, I am telling you about various types of forces in nature. Various types of forces, fundamental forces in nature. Which forces? Fundamental force. There are four fundamental forces. One is nuclear force. Another is electric force, in which electrostatics comes into picture. Another is weak force that takes place inside nucleus. And another one is gravitational force. If we look at general comparison of nuclear force, electric force, weak force and gravitational force, the nuclear force is most powerful force among four fundamental forces. But the only problem with the nuclear force that it acts only in the nuclear range. What is nuclear range? Nuclear range is 10 power minus 15 meter to 10 की power minus 12 meter. When separation between two nuclear particles remains of the order of 10 power minus 15 meter, nuclear force remains most strongest. And when separation between nuclear particle becomes 10 power minus 12 meter, so strength of the nuclear force becomes 0. Means nuclear force is a saturated force, okay? It operates only in a very small range, okay? Beyond nuclear range, electric force is the most powerful force, okay? Beyond nuclear. Suppose in the question if somebody asks, if two protons are separated by a distance of 10 power minus 6 meter, if two protons are separated by a distance of 10 power minus 6 meter, which of the following force will be most powerful? Then definitely out of four fundamental force, electric force will be most powerful, okay? And gravitational force is the least powerful force, okay? So if you just make the comparison among the strength, so nuclear force is powerful, then electric force is powerful, then weak force is powerful, than gravitational force. Gravitational force is the weakest force among four fundamental force in nature, okay? This is the brief comparison of the strength of the force, four fundamental forces. Now, this Coulomb's law is a medium dependent force. Coulomb's force is a medium dependent force, okay? These are some important points about Coulomb's law. First thing, when 2-point charges Q1 and Q2, when 2-point charges Q1 and Q2 are separated by a distance r in air or vacuum, when 2-point charges Q1 and Q2 are separated by a small distance r, by any distance, when 2-point charges Q1 and Q2 are separated by a distance r in air or vacuum, then electrostatic force acting between them is directly proportional to strength of charges, inversely proportional to square of distance between them. And if we write by writing constant of proportionality, this 1/4 pi epsilon 0 is a constant of proportionality whose value is 9 into 10 power 9 in electrostatic SI unit, okay? Q1 Q2 upon R square. Now some important points about this electrostatic force is this. This electrostatic force is a medium dependent force. This is a medium dependent force. The direction of electrostatic force always remains along the line joining two point charges. Direction along the line joining two point charges. Okay. Now in medium what, and this is a action reaction force. This is a action reaction force. Okay. Now if you talk about this force in a medium, if these two charges Q1 and Q2 are kept in a medium of dielectric constant epsilon r at a distance r, then in medium you can write the formula F medium equal to 1 upon 4 pi epsilon 0 epsilon r. What is epsilon r? This is relative electric permittivity of medium. Epsilon r is what? Relative electric permittivity of medium. And this is equal to epsilon upon epsilon 0. What is epsilon? This is absolute electric permittivity of medium. And what is epsilon 0? This is absolute electric permittivity in vacuum or air. Okay. The value of epsilon 0 is standard. This is 8.85 into 10 to the power minus 12. Farad upon meter is unit. This is value of epsilon 0. Okay. So force in medium equal to Q1 Q2 upon R square. If you just compare the two equations, F medium, F air, you will come to know F medium equal to F air divided by epsilon r. So since value of epsilon r for any medium is greater than 1, therefore F medium is less than F air. Means in the presence of medium, electrostatic force decreases. In the presence of medium, electrostatic force decreases. And if you place conducting metal between the charge, okay, for metals, value of epsilon r equal to infinity. In presence of metal, force will become 0. Okay, in presence of metal, the electrostatic force between two charges Q1 Q2 will become 0. Okay, this is also very important point.